Every year, over 200 billion steel bolts are produced worldwide, each one going through a complex multi-step process that ensures its ability to withstand incredible forces. This tiny powerhouse plays a crucial role in everything from constructing skyscrapers to assembling automobiles, making the precision of its manufacturing process not just impressive, but essential. Join us as we delve into the intricate world of steel bolt production, where engineering meets exactitude on a massive scale. Cold forging. It all starts with large steel wire rods, which are first uncoiled and then cut to the exact length needed. The steel used is pretty standard, following the strict guidelines of ISO 898-1 to ensure quality. Now here's where the magic happens. The steel wire is cold forged into the perfect shape. This means the steel is molded at room temperature by being forced through a series of specialized dies under high pressure. And these tooling systems, they're seriously intricate, sometimes made up to 200 different parts, each with super precise tolerances down to hundredths of a millimeter. Thanks to cold forging, manufacturers can crank out bolts super fast in huge quantities, and each one is just as good as the last. It's a cool mix of precision, speed, and reliability, all without heating up the steel. For bolts that need more detailed shapes or features, manufacturers often turn to processes like turning and drilling. Turning is pretty cool. It involves spinning the bolt super fast and then cutting away bits of steel to sculpt it into the exact shape and design needed. It's like watching a potter shape clay, but with steel and high-speed machinery. Then there's drilling, which is used to punch precise holes right through the bolt. Sometimes, especially if the design calls for it, bolts might even get washers attached at this point in the process. So there's quite a bit of high-tech craftsmanship involved in bringing those more complex bolt designs to life. From spinning and sculpting to drilling through tough steel, it's all about precision and making sure each bolt is perfect for its purpose. Cool, right? Heat treatment. Let's dive into how bolts get that tough exterior through a process called heat treatment. This involves blasting the bolt with extreme heat to harden the steel, making it more durable. Typically, the threading, which is the spiral ridge around the bolt, is added before this heat treatment. There are a couple of ways to do this: rolling and cutting. Rolling is pretty similar to cold forging. The bolt is run through a die that molds the steel into those neat threads you see. Cutting, on the other hand, carves out the threads by actually removing parts of the steel. Why thread before heating, you ask? Well, it's because the steel is softer and easier to work with at this stage, which makes it not only easier, but also cheaper. However, there's a trade-off. Threading after the bolt has been hardened can actually improve its fatigue performance, making it last longer under stress. Henrik Oskarsson, an expert in the field, points out that heat treatment isn't perfect. It can leave heat marks and even cause minor damage to the bolt. That's why some high-spec applications like engine and cylinder head bolts might require threading after heat treatment. Yes, it's more expensive since you're working with hardened steel, but this way the threads are less likely to deform under pressure. So there's a lot that goes into making sure bolts can do their job right, especially in places where they really need to hold up. Isn't it fascinating how much technology and planning is behind something as small as a bolt? Size and surface. Let's get into the nitty-gritty of making long bolts, those where the length is over 10 times the bolt's diameter. These bolts pose a unique challenge because after heat treatment, they tend to want to go back to being round like the original steel wire they were made from. To fix this, they need a bit of straightening to keep them nice and linear. When it comes to finishing up a bolt, the type of surface treatment it gets is super important and depends on where the bolt will be used. A big concern with fasteners is keeping them from rusting, so a popular choice is a zinc-plated coating. This is done through an electrolytic treatment where the bolt is dunked in a zinc solution, and an electric current is used to fuse the zinc onto the bolt. This method is great for fighting corrosion, but it does have a downside called hydrogen embrittlement, which can make the bolt brittle. For those who need even more corrosion resistance, zinc flakes are an option, though they're pricier. And if the bolt is going to be in a place where it's oiled up, like inside an engine, a phosphate coating might be used instead, since it's more cost-effective and corrosion isn't as much of a worry. After surface treatment, most standard bolts are ready to go, but more complex designs might need extra steps like adding brackets or applying a patch. There are a couple of patching options: a locking patch, which is a thick nylon layer that helps the bolt grip better, or a liquid patch, which improves how the threads form torque. Once all these processes are done, the bolt is complete, but it's not ready to ship out just yet. The final step is quality control to make sure every bolt meets the high standards for uniformity and consistency. After passing QC, they're finally ready to be packed up and sent off. As we've explored the intricate steps of steel bolt manufacturing, from the initial melting of raw materials to the precise threading and quality testing, it's clear that these small components are more than just pieces of metal. They are the unsung heroes of structural integrity and mechanical reliability. Next time you pass by a building, a bridge, or even drive your car, remember the meticulous craftsmanship and advanced engineering that go into each steel bolt. Their strength and resilience remind us that great things often come in small, precisely crafted packages. If you enjoyed this deep dive into the fascinating world of steel bolts, don't forget to like and subscribe for more insightful content like this.